Hi, in this video we are going to take a look at the grep tool and the basic regular expression that it allows us to use to make something beyond simple matches that we already discussed in a previous video. So this slide kind of summarizes the content we're going to address in this video. We are going to start with the basics of matching, okay? Meaning the syntax, the regular expression syntax, and more specifically the basic regular expression syntax that allows us to match any character except the _n, meaning the end of line. To match any character, any single character that is comprised in a set of characters. For example, if I type this, square bracket, QWE, square bracket, then what I'm saying here is that I want to match one character. So this whole expression is one character that is either Q, W, or E. And then the last syntax we're going to look at is what if we want to match a single character again. So this whole expression matches one character, which is not Q or W or E. Okay, so the hat symbol, when located at the beginning here of the square bracket, means negation. So it's a complementary set compared to what we specify here, the letter we specify here. So please note that the hat symbol is at the beginning, right after the opening square bracket. It's not in any of those three positions. It's not at the end, it's not in the middle, it has to be in the beginning to be interpreted as pretty much negation. So what we are going to do is we're going to take those three syntaxes and we are going to first illustrate them on our Linux virtual machine. So let's move to the shell. There we go. So we have a data file appropriately named data file, and we are going to grep lines from that file. So I'm going to fill it with different words, random words, made up words. Okay. So I'm using something, and I'm making pretty much variation on the word something right now. Okay. I'm just replacing the first letter. There we go. Let's add one more. So we have 5 variations here on the word something. So we're going to use regular expression. When you use regular expression with grep, I strongly recommend that you use the single quotes to delimitate your regular expression. Okay, we're not going to get into bash quoting techniques in this video, but the single quotes are going to allow you to prevent the bash shell from trying to interpret part of your regular expression and then pass to grep something that is not what you actually intended grep to receive. So the single quote is going to pretty much encapsulate your regular expression and make sure that it is given verbatim to grep, just as you typed it. So let's start with something simple. Okay, if we just type here something, well, we match obviously the word something, the line that has the word something. If we type something, well, we get every line, but you can see that grep has not been matching the entire word. Okay, it has been matching just what we type, which is thing, as a substring in each of those lines. So what if we want to match actually the entire word? Well, this is when we're going to use the dot. Okay, the dot in this example is going to allow us to actually say any character followed by omething. Okay, this is a substring I'm trying to match. So you can see here that we have been matching the entire words because of that notation. Alright, so now what if we want to match some of these only? For example, we want to match something and something. Okay, so the one starting with a H, and the one starting with a S. Well, the dot is a little bit too general for this. This is why we have this square bracket notation. Square bracket notation, again, allows us to specify what we want to see as that first character. So the whole expression is for one character. And we are going to say that it can be a S or it can be a H. Right? So if I specify this, then you can see that I'm matching every line. And I'm matching inside the line the entire word something or the entire word something. Okay? So obviously we're not limited to 2 characters. Okay? I can have something, something, Q something, no problem. So you can specify as many characters as you want here. I would like also to point out that the order in which you specify the character is irrelevant. It just so happened here that I use S, H, and Q, and this is the order actually in which the word appear in the file. Okay, but if I do Q, H, S, I get the same input. the same output. So remember that grep is going to read your file from start to end, and for each line is going to try to match the pattern that you specify. And if the pattern matches one or more time in that line, it displays on the screen the line. Okay. So that means that the order in which the lines are going to appear is based directly on the order in which they appear in the original data file. It has nothing to do with the order in which you specify, those characters in the set notation. So now the next thing we can do with that set notation is, as I mentioned already, get the complementary of it. So if I look at this data file, I have matched right now the first three lines, okay, with my expression. What if I want to get every line that doesn't match this pattern? Well, I can simply say I want every line that has thing in it. I don't need to modify this, okay? But at the same time, I can say I do not want to see any of the character Q, H, or S at the beginning of the word. And if I do that, I'm going to show the data file. You can see that we matched actually the next two lines, the lines that do not actually follow that Q, H, or S at the beginning pattern. So that gives us an overview here of what we can do with basic matching, pretty much. Now, I like to introduce very early on that backslash symbol here, because when we learn about basic regular expression or regular expression in general, there's a lot of special characters that have a special meaning in those regular expression. Now, very quickly we are going to wonder, what if I want to match a dollar sign, or what if I want to match a dot in my example, or a square bracket, an opening square bracket, a closing square bracket. So all those signs, all those symbols right now are off limit. We could not, have a text with a dot in it and match that dot. So to be able to do so, we need actually yet another syntax that tells us we are going to neutralize the special meaning of the character following the backslash here. So if I type backslash dot, this dot here is no longer the dot, the special dot meaning any single character. It is actually just a plain and simple dot. Let me illustrate this. So let's take our data file. What if I have here a sentence, let's say something else, and then more dots. Okay, or something again, and else, or else, dot dot dot, and else again. I'm trying different combination here. Else 5, 6, 9. Okay, so we have the word else with a bunch of things after it. Okay, so what I'm going to do here, I'm going to start easy, data file. I'm going to match else. So I can match the word else without problem. Okay, that's basic grep usage. But I cannot match a dot that's after. It's giving me every line that contains a substring s, even if it's part of a bigger string, like the free example on this output. So now I would like to be able to say I want to match else followed by one dot. To do this, I could write first attempt, else dot. It looks like it's working. Okay, if you look at the first line, else dot, great. Then the second line, else dot, and then two other dots that I ignored. But yes, okay, I have specified else dot as substring, so they should match indeed. And then this is where it starts going wrong. We have else with an exclamation mark that's matched, a question mark, a 5. And why is that so? Well, it's because the regular expression we uses a special character dot, which means any character. So just about anything that would come after the else. I can even here have else and a space. Okay, 3 spaces. I save my file. If I apply again this pattern, you can see that the first space was matched. Obviously, it's not really clear here because the coloring of a empty space, a white space, is not really visible on the screen. But that's what is happening actually. This space is also captured by our regular expression, matched by our regular expression. So that's not really what I intended to do. What I intended to do is to say I want else followed by just a plain old dot. So I want to tell grep that I'm going to write a dot, but I do not want grep to interpret this dot as if it was, the the regular expression syntax. To do so, I anti-slash it, I backslash it. If I do this, then you can see that we are actually matching exactly else followed by one dot, and that's it. Now, if I add several dots, okay, if I just put several dots like that, it's easy to believe here that the backslash is applying to all the dots. Okay, actually, it's easy to believe if you look at the second output here. Okay, but if you look at the first output, the first line that's matched, you can see that I match else followed by a dot, then a space, then an A. So that means that the first dot was indeed neutralized, but then the two subsequent dots were interpreted as any character. So this example alone shows it. Okay. Just keep in mind when you use backslash, the use of backslash is that it neutralizes only one character. Okay, so if I want to neutralize several characters, I need to backslash each of them. In this example, I want to obtain dot dot dot. I want to match else dot 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 in my text file. Then I need to use 3 backslash character, 1 for each dot. And if I do this, then I have efficiently neutralized actually each dot in my regular expression. So we are going to rely a lot on backslash. We're going to rely a lot on backslash, like I said, simply because we are going to introduce more and more of those special syntax, and we need to have a way to pretty much be able to match all those symbols inside text files. For example, let me just take a few more examples. If I have something like, hey, what if I want to match else between square bracket? Okay, same thing is going to happen here. So if I do grep, I'm going to modify, I'm going to restart data file, there we go. It's going to be easier. If I match else, okay, I get all the matches. If I put a square bracket here and a square bracket there, well, here's the problem. Square bracket around the word else is really not a word. This whole square bracket expression represents one character. One character that can be E, L, S, or E. So I match a S here, I match a E here, I match a E, then I match a S, L, sorry, then a S, then an E here. But this is not the word else. I match each character individually, right? Because a square bracket notation represents only a single character. So sometimes it looks almost like it's working here or here, but you can see that I have not captured actually in my regular expression, I have not matched the square brackets at all. So be careful when you check that your regular expression is working, right? You don't want to, you want to have enough examples so that you make sure that actually your expression is doing what you think it's doing. In this case, it's not. And if I want to match actually the square bracket, I need to backslash it. So that would be how to do this. Okay, I backslash the first square bracket, the second square bracket, and then only when I have else surrounded by square bracket in my text file, it's going to be matched, and it's going to be matched including those square brackets. Now the same thing is going to happen for backslash. Okay, it's interesting because the backslash can be actually neutralizing itself. So I'm going to put a backslash in my text, and I'm going to use else again because we have so many occurrences of it. That's great. So if I do again grep in my data file, else, okay, I match everything. I do not match the backslash. Okay, now I want to match the backslash. Well, if I put one backslash, here's what's happening. Nothing really. Still, it's the same match. Okay, why? Because backslash e means actually backslash is a special character, and it means neutralize any potential special meaning of the next character. So in this example, if e had any special character in a special meaning, sorry, in a regular expression, if e was a special character, it would be neutralized. Well, e is not a special character. It doesn't have any special meaning in a regular expression. So neutralizing it doesn't really make sense, doesn't really do anything. That just means the letter e. Okay, so doing this or doing this is exactly the same thing, as you can see. Okay, now why did that go wrong? Why didn't that work? Because when I introduced the backslash, I didn't tell grep to match a backslash. I told grep, let me use a backslash syntax in my regular expression. So grep associated a special meaning to the backslash, the same way that it associates a special meaning to the square bracket or to the dot symbol. So as with the dot symbol and the square bracket, if I mean to say match a backslash in the text of my data file, I need to backslash it. So it's a little weird the first time you encounter this, but it's relatively simple to understand. I mean, the first backslash is actually you telling grep that you are trying to neutralize a special character meaning, and the special character you're using is backslash. So you neutralize it, which results in a backslash. Now when I try to match this, you can see that it's doing actually the job intended. So don't get misled by this example. Think of it, it's exactly the same thing as a dot. Generally people understand very well the dot. The backslash makes a few people pause and wonder what's happening exactly here, but there is really nothing new going on. It's not an exception, it's just us applying the backslash rule, okay, to itself. So this allows you to use all of those characters, including the backslash, in any expression that you are actually using. Now we're going to move on to anchors. Okay, this is the last part of this video. We are going to discuss special symbols that allow you to match a certain regular expression. So it can be a basic word, it can be a regular expression using the dots, the square bracket notation, backslash. It can be any regular expression, no matter how complicated. But it's going to allow us to anchor that regular expression at a specific position on the line of text that we are reading from the file. So let me start by the two symbols, hat and $sign. These are the two easiest symbols to explain. So let's take an example here on our data file. If I move to the shell, here's the data file. Okay, let's say that we have the word else sometime at the beginning of a line. Like for example, right here. I'm going to put it at the beginning of the line. Sometime we are going to put the word else at the end of the line. Okay, for example here I'm going to make sure that it's at the end of the line, and I'm going to have two examples of each. Okay. There we go. So we have two lines where else is at the beginning, two lines where else is at the end. So if I try to just use a basic grep, okay, with else, it's going to give me all the lines. So this is where anchors can be useful. If I specify that I want to match only when else is at the beginning of the line, I use the hat symbol. And you can see that this is working. So the hat symbol is a special character, again. It has a special meaning in a regular expression, and it's interpreted as beginning of line. So the beginning of the line is not really a character that you match, but using the hat symbol allows you to say, hat is going to represent the beginning of the line, and then I want to find an E immediately after the beginning of the line. So this is how it's working pretty much. Now, interestingly enough, if you have, let's say here an example where we have space, 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 else with 3 spaces before it, before whatever. Save. And I'm trying to match this. You can see that this is not being matched, because technically there are 3 characters between the beginning of the line and the E. So if I wanted to match this, I would have to specify here the 3 space character, and then that would work. Alright. The same thing happens for end of string. End of line, sorry. If I specify else, and I am putting the $sign right after else, I'm going to match all the lines that have else followed immediately by the end of line. So sometimes it's tricky because, for example, if this one here has a single space even after it, well, there we go, it's not matched anymore. Okay, I added a space here, so the line with F something is not being matched. So you have to be careful about the format of your text. I mean, sometimes it looks like you have 2 occurrences of else at the end of a line, but if you have even just a space here, it's not going to work out. So we have used the hat symbol, we have used the $symbols to delimitate beginning and end of line. Obviously, we can use both in a regular expression. For example, we could say, well, let's say that some lines have else. Let's call it else 1, else 2, else 3. Okay, we have 3 lines here that have the word else in them, followed by a number. So if I do again, simply else match, okay, I get everything. If I do else with a hat here, I get all the lines that start with else. But if I want, you know, all the lines that have only else followed by a number on them, I can do it like this. So, I mean, if I do it like this, I would require to have a line that has else by itself. For example, let's remove the one here. There we go. Any line that has a word by itself will be matched. If I want to match a one that have actually a number after one, I can do it in 2 ways. A general way is to say, okay, I'm going to allow else and an extra character, whatever it is, and delimitate it, you know, between beginning and end of line. So there we go, else 2 and 3 are there. Or I could say here, I want to match anything, and this would be more specific. Okay, this is better. I want to match anything that is else followed by the number 2 or 3, so I allow only else 2 and else 3 to be matched, and I want to make sure that this is the only word on the line. Okay, so if I go here and I say, well, this is else 2 and this is else 3, when I try to match this, these are not matched because there's more actually on the line. Okay, more at the beginning, more at the end. This is not just comprised between the beginning and the end of the line. So this is why we refer to these as anchors. Okay. So let's take a look at the remaining anchors that we haven't yet discussed about. We have this time we have like two symbols here used to mark actually the beginning of the word and the end of the word. And unfortunately, those symbols use the backslash, so that makes it a little confusing here with what we have learned about the backslash. But if you think about it, it's just a matter of context. For example, here we've seen that the hat symbol means beginning of line. But if we put the hat symbol as the first character in a set notation using the square bracket, then it has a different meaning, right? So the context in which you use the hat symbol makes a big difference. So you could encounter square bracket hat, you know, some letter square bracket, and you know that this is just a negation for the set syntax. If you encounter hat by itself outside this notation, you know it's the beginning of the line. If you encounter backslash hat in an expression, that means we neutralize hat, so it's just trying to match the character hat in the text from the file we are working with. Okay, so we have encountered already symbols that have different meaning in different situations. Same thing here with the backslash. Okay, you encounter the backslash anywhere else, you're going to understand it means I neutralize the special meaning of the following character. Here, if you encounter backslash followed by lesser than or greater than, you know it has a special meaning by itself, beginning of word, end of word. So these are really useful. Beginning of word and end of word are really useful to actually implement something that we already covered as being an option of grep. Okay, there's an option in grep that allows you to match actually a word that you specify as being a word, not a substring. We already talked about that in the previous video. Here, same thing. If we want to match else, and I'm going to type random character here, okay? So we have some occurrences of else that are actually the word by itself, and some occurrences that are actually else appearing as a substring of something else, okay? Talking about which I could write here, something else goes right here. So else again is a substring here. So as we have already discussed in previous videos, if I try to match else, it's going to match else anywhere. It matches a substring s in the string representing the line. Now sometimes we want to be more specific. We want to say, you know, I'm talking about the word else. What does it mean to talk about the word else? That means that before and after else there should be separators. So let's see how we can use this new notation to indicate we want to match really the word else. So okay, we pretty much put around the word else the backslash lesser than, backslash greater than, and you can see it's working here. It's working when the word else is by itself, okay, like here, like here. It's working also when else is followed by a punctuation sign, because punctuation is actually considered to be a separator between words, okay, like a comma, a dot, question mark, exclamation mark, dot dot dot, etc. Even the symbols like backslash and so on and so forth are going to be considered separations between words. So this allows us to write an otherwise complicated regular expression where we would have to say I want else, I want to find else, but after else I don't want to find a space, for example. Okay, I could write this like so, okay, but then that would only take into consideration separators that are, sorry, not, I should not have used a negation here. If I use space and space, this is definitely not playing nice right now. Let me think about this one here. If I say I want to see a space here and I want to see a space here, I'm going to have to use a special notation I'm going to introduce in the next video, so I'm not going to do that now. But pretty much I could build actually a regular expression that's a little bit more involved, that's going to allow me to specify separators around the else. But the problem is that I would have to specify all the separators. I would have to say, for example, I'm going to accept a dot, I'm going to accept, what else? I'm going to accept a question mark, I'm going to accept an exclamation mark, etc. Okay? So if I do this and I specify all the separators that I'm going to accept here, then it's going to be okay. But if I do not specify all the separators, if I omit some, if I forget some, etc., then it's not going to work. Okay? For example, here, and you are going to note here, by the way, as I was talking, I fixed it, that you have to backslash actually those characters when you use them in set notation. If you use any special character, you are going to actually have to backslash them to say I mean that very character, not its special meaning in the expression. So if I do this and I craft it cleverly, then I'm going to be able to reproduce the same thing, but I have a much easier notation to do that already for me, which is a backslash greater than and lesser than notation. So that allows me to delimitate words here. And with this, we are done with our overview of the fundamental, pretty much basic regular expression that are used with the grep tool. So thank you for watching.